Welcome, ladies and gentlemen. Today we're going to be talking about evaluating trigonometric functions of any angle. So you're definitely going to want to put all of these things in your notes. You're going to need a pen and a pencil and a calculator. All right, here we go. This first thing is very, very important. We have to have this in our notes. We're going to be talking about a reference triangle, which is a triangle created when you draw a line from the terminal side perpendicular. Remember, perpendicular means that we're going to create a right angle, okay, to the x-axis. Then we're also going to be talking about what's called a reference angle. The angle that is located at the origin, very important, it's located at the origin in the reference triangle. So if I would give you an example, if I said we're going to draw a 235 degrees. If I start at my initial side, which is always my positive x-axis, and I go 230, so I have to go past 90, past 180, but before 270. So it's going to be somewhere around here. When I draw this angle at 235 degrees, now I'm going to put in my reference triangle. When I do that, I need to create a perpendicular line from my terminal side, which is here, to the x-axis, which is here. So I'm just going to draw a line straight down, create my right angle. I have just now made my reference triangle. Now I have to make my reference angle, figure out what that is. So my reference angle is this angle right here, because it's at the origin, and I need to know how big this angle is. Well, my first initial mark that I made was 235 degrees, and the closest one is 180. So I'm going to take 235 minus 180, and I get 55 degrees. So I know this angle is 55 degrees. That's how we're going to make our reference triangle and our reference angle. Now we're going to do quite a few examples of this. Please put them all down. It's very important that we know how to do this in order for us to do all of the work upcoming. Okay? So here's our first two examples. We need to sketch the angle, the reference triangle, and then find the reference angle. So our first one here, we're going to do 210. We start with our initial side. Now 210, here's 90, here's 180, here's 270. Between these two, I'm going to put it right here again. Here we go. This is 210 degrees. Now I have to make my reference triangle. To do that, I'm going to use my terminal side, and I have to make it perpendicular to my x-axis. So I'm going to draw a straight line from my terminal side straight up to my x-axis, make my 90-degree angle. Now my last thing I have to do is find my reference angle, which is right here. My angle is always touching the origin right here. In order to do this, I'm also closest to 180 again, so I'm going to take my 210 minus my 180, and I am going to get 30 degrees. So I would put 30 degrees for that angle. All right, moving on to the next example. First thing we're going to do is graph the angle 110. So I start my initial side, have to go past 90 but not quite to 180. So I'm going to go right about here. Here's my angle at 110. Now remember, to make my reference triangle, I'm going to use my terminal side and my x-axis. My x-axis is right here. Now this time I'm going to bring my perpendicular line straight down. Now I've just created my right reference triangle. Next step, I have to find my reference angle. So I'm looking for this angle right here. Now I'm at 110. I need to make it all the way to 180. I need to know how far it is to that point. So once again, I'm just going to take 180 minus 110, and I'm going to get 70 degrees. So 70 goes right here. Now, one thing to remember about this reference angle, it's always going to be positive. So if you did 110 minus 180 and you get a negative 70, it's still going to be a positive 70 because all of our angles that we're working with for our reference angle are positive. All right, we have two more examples with using degrees. So make sure we get these down. These ones are a little bit different. This one we're going to go negative 130. So I start with my initial standard side. Here would be 90 because I'm going negative. Here would be 180. I'm between the two, so I'm going to be about right here. This is a negative 130 degrees. Make my reference triangle. To make my reference triangle, use my terminal side and my x-axis, which is right here. This one, once again, terminal side, go up to my x-axis, create that right angle. Now, last but not least, find this reference angle. To find the reference angle, I'm going to use this again. I'm going to take 180 minus 130, and I am going to get 50. So this is 50 degrees is my reference angle. Reference angle, remember, always at the origin right here. Next one, we have negative 295. So here would be 90. Here's 180, 270, then we come all the way back to 360. So we start here at our initial side, have to go all the way over here. So we can go all the way around because it's negative 295. Now I need to make my reference triangle. When I make my reference triangle, I use my terminal side and the x-axis. Now this x-axis is going to be right here that it meets. So I bring it straight down, create my right reference triangle. There it is. Has to be connected to the x-axis. Now I have to find my reference angle. For my reference angle, this one, I'm closest to 360, so I'm going to take 360 minus 295, and I'm going to get 65 degrees. So I have 65 degrees right here. All right, moving on, we have two more that are very similar to this, ladies and gentlemen, except for now, if you notice, I'm not given a degree anymore. I'm given radians. So the very first thing we have to do for this is change it from radians to degrees. So if I set this up, I'm going to have x over 360 equals 5 pi all over 3 all over 2 pi. To solve this, I'm going to cross multiply, so I get 2 pi x, equals 600 pi. So make sure you can get 600. You're taking 360 times 5/3 here. Divide both sides by 2 pi, and x equals 300. So now that I finally know my degree of my angle is 300, I can go ahead and graph this like I have been. Start with my initial side, 300, so 90, 180, 270. I'm going to be all the way over here. So I have a positive 300 degree angle. Now, reference triangle. So I use my terminal side. And I have to use my x-axis, so I'm going to be using this right here. Now I'm going to create my triangle by going from my terminal side straight up to my x-axis, making my right angle there. They're perpendicular. Once my reference triangle is made, I need to make my reference angle, which touches the origin, so it's always going to be this one right here. For this one, I'm working with 300, so I'm going to go 360 minus 300. I have 60 degrees, so my reference angle is 60 degrees. Alright, last example like this, I promise, I promise. So when we set this up, once again, we have to find our degree of our angle first. So I have x over 360 equals negative 7 pi all over 9 all over 2 pi. Now we're going to cross multiply, so I get 2 pi x equals, now we're taking 360 times negative 7/9, and I get negative 280 pi. Now to solve this, I'm going to divide both sides by 2 pi, and x is going to equal negative 140 degrees. So once all of this is said and done, I'm going to graph negative 140. So I start in my initial side. This would be 90. This is 180. So it's going to be between 90 and 180. Put it about right here. Negative 140 degrees. Now it's time to make my reference triangle. Use my terminal side and the x-axis. Now from here I can drop it straight down, make my right angle. There's my reference triangle. Now it's time for my reference angle. Reference angle, always at the origin. So it's right here. Here, once again, I'm going to go 180 minus 140. So I have a 40 degrees right here. My reference angle is 40 degrees. All right. Now that that is all said and done, and we are going to be pros after all 6 of those examples, next one is a little bit different and new. So I want you to write this down for me, please. Not this, you don't have to write the words, just the picture. But by understanding the reference angle and the reference triangle, we can now evaluate all 6 trig functions for the triangle that we create. We're going to be creating a triangle, ladies and gentlemen. I'm going to be giving you a point, so we want you to have this picture. That's all you have to have in your notes on the slide. We're going to be finding a point, and we are going to be creating this triangle right here. Okay? So we're going to do 2 examples like this. Here's our first example. We're going to evaluate the 6 trig functions of theta given that negative 4,3 is a point on the terminal side. So that terminal angle that we've been working with this whole time. So first things first, you have to create a coordinate plane. So I create my coordinate plane, my x and y axis. Now I have to go to this point. So I'm negative 4,3. So if I start at the center, I have to go negative 4. So I'm going to put this here. And then I have to go up 3. Well, ladies and gentlemen, I have just created, here's my point on my terminal side, so I can create my terminal angle right here. This point is negative 4,3. Now, by plotting that point, I've also created 2 of my side lengths of my right triangle, because we just made my reference triangle, what we've been working with. Now, in order to find all my 6 trig functions, I need to find my third side. In order to do that, I'm going to use Pythagorean theorem. So I have 3 squared plus negative 4 squared equals x squared. 9 plus 16 equals x squared. 25 equals x squared. Square root of both sides. 5 equals x, or my hypotenuse. So I'm going to put 5 right here. Now, it's very important, ladies and gentlemen. Our reference angle has not changed. So when we're looking for theta, it's not going to be in our picture. We have to put it there. Always at the origin, just like it has been. So we'll put our theta right there. Once we have that angle in and we know all 3 sides, label our triangle. This is the opposite. This is the hypotenuse. This is the adjacent. Once we do all that, we can now find all 6 trig functions. So when we're doing this, sine is opposite over hypotenuse. So the opposite of this is going to be 3 over 5. Next one we have is cosine. Cosine is adjacent over hypotenuse. So we're going to have negative 4 all over 5. Now we have tangent, which is opposite over adjacent. So 3 over negative 4. Now, if we remember back, we've already done this. Sine and cosecant are reciprocals of each other. So this one's hypotenuse over opposite, so 5 over 3. Cosine and secant are also opposites of each other, so this is hypotenuse over adjacent, or 5 over negative 4. And last but not least, tangent and cotangent are opposite of each other, so this is going to be adjacent over opposite. My adjacent is negative 4. My opposite is 3. Okay? Now, ladies and gentlemen, promise this next one is our last example. Make sure it's in your notes. It's very important. Same idea. We're given a point 3, negative 3 on the terminal side. We need to evaluate our 6 trig functions. So, need to draw my x and y axes. So I'm going to plug that in here like I did before. Now I'm going to start creating that reference triangle. So I need to go to the point 3, negative 3. So I'm going to go right, start at the center, go right 3. Then I'm going to go down 3. So this is going to be a negative 3. At this point, which is through that terminal line, so I can create that line right there, I am at 3, negative 3. This is going to be my right angle. Now I have to find my third side, my hypotenuse. So I have 3 squared plus negative 3 squared equals x squared. 9 plus 9 equals x squared. 18 equals x squared. Square root both sides. Now 18 is not a perfect square, but the perfect square that goes into 18 is 9. So it's going to be 9 and 2 equals x. The square root of 9 is 3. Square roots of 2 equals x. That is our hypotenuse. So right here I'm going to have 3 square roots of 2. Now before we start labeling it, we have to have that reference angle. Remember, always at the origin, here's my reference angle. In this case, we're calling it theta. So from here we have opposite, adjacent, and hypotenuse. Now we can go fill out our 6 trig functions. So on our first one, when we're working with sine, sine is opposite over hypotenuse. So the opposite is negative 3, and the hypotenuse is 3 square roots of 2. Now we can't have a square root on the bottom, and this has to be simplified. First thing, my 3's can cancel, so I get negative 1 over the square root of 2. To get rid of the square root of 2, we have to multiply the top and the bottom by the square root of 2. So I get negative square roots of 2 all over 2 as my final answer for sine. Now if we look at cosine, cosine is adjacent over hypotenuse. My adjacent is 3. My hypotenuse is still 3 square roots of 2. To simplify this one, the 3's cancel, so on the top I'm left with 1 over the square root of 2. To get rid of the square root of 2, multiply the bottom and the top by the square root of 2. So I get the square root of 2 over 2. Now for tangent, tangent is opposite over adjacent. So I'm going to get negative 3 over 3, which is just negative 1. Now, sine and cosecant are opposites. So this is hypotenuse over opposite, which is 3 square roots of 3 over, square roots of 2 over negative 3. The 3's cancel, and I get negative square root of 2. Secant and cosine are opposites. So I have hypotenuse over adjacent. My hypotenuse is 3 square roots of 2 all over my adjacent, which is 3. My 3's will cancel, so I'm left with the square root of 2. And last but not least, my cotangent is the opposite of my tangent. So I have adjacent over opposite. My adjacent is 3. My opposite is negative 3. When I simplify this, I get negative 1. And there we have found our 6 trig functions. All right, ladies and gentlemen, we are done. I hope you have a fabulous day, and I will be seeing you later. Bye.